There is a fungus that can hijack an ant's body, march it out of its colony, and lock its jaws onto a leaf. Where it dies, its body no longer its own to command. And that is only the beginning. Before these 8 minutes are over, you'll meet a worm 3 times longer than the cricket it grew inside, one that drives its host to drown itself, a fungus that doses a cicada with a stimulant related to amphetamines and the compound found in magic mushrooms, and keeps it flying and mating long after part of its body has been replaced by spores, and a parasite that turns a snail's eyes into pulsing striped lures that all but scream, "Eat me," to passing birds. None of this is science fiction. It's all real, and every one of them does the same impossible thing. It takes control of another living mind. Welcome to the lab. Today's specimens are the puppeteers, the parasites that don't just infect a host, they drive it. If that's your kind of unsettling, the subscribe button keeps the lab doors open. First specimen. We start with the one from the intro. Ophiocordyceps, the zombie ant fungus. It infects a carpenter ant and spreads through its body, but here's the twist scientists only recently confirmed. It never actually invades the brain. Instead, the fungus grows around the ant's muscles and works them directly, like a puppeteer pulling strings on a body whose command center has been left switched on but powerless. The infected ant leaves its colony, climbs to a precise height, and locks its jaws onto a leaf in a death grip it cannot release. Then it dies, and a stalk grows from its head, releasing spores onto the ants below. That's what makes it so unsettling. The brain is intact the entire time. The body is simply no longer taking its orders. A fungus takes weeks. This next predator does it in seconds, with surgical precision. The Jewel Wasp. It hunts cockroaches far larger than itself, and it doesn't kill them. It stings twice. The first sting briefly paralyzes the front legs. The second is the precise one. It guides its stinger through the roach's neck and into the brain, using sensors on the tip to find the exact spot, then delivers venom into the region that governs the will to move. The cockroach can still walk, run, even fly if prompted, but the drive to escape is simply switched off. The wasp then takes it by the antenna and leads it into a burrow like a dog on a leash, lays a single egg, and seals the chamber, leaving the docile host as a food supply for its larva. That wasp controls one host. This next parasite runs a whole assembly line of them and sacrifices itself to do it. The Lancet Liver Fluke runs one of nature's most elaborate relays. It passes from a cow to a snail to an ant and back to a cow. When an ant swallows it, several hundred flukes pour in, but only one breaks away and burrows into the ant's brain. That single fluke becomes the driver. Every evening as it cools, it leads the ant up a blade of grass to clamp on and wait, parked all night exactly where a grazing cow is likely to eat it. If sunrise comes and no one has, it walks the ant back down so it won't overheat, then repeats it the next night. And here's the twist. When a cow finally eats the ant, the driver fluke in the brain is destroyed by stomach acid. It sacrifices itself so the hundreds waiting in the abdomen can reach the liver and breed. So far, the hosts at least die out of sight. This next fungus turns its victims into bait for their own kind. Entomophthora, a name that means insect destroyer, infects houseflies. It grows into the brain and triggers what scientists call summit disease. The dying fly is driven to climb as high as it can, anchor its own mouthparts to the surface, raise its wings and freeze in place, a perfect launch pad for the spores that erupt afterward. But it has one final strategy, and it's a dark one. The cadavers of infected females release a chemical signal that draws healthy males in to mate with them. And in doing so, the males are infected too. The fungus turns attraction itself into a delivery system. Quick pause. We're halfway through the lab, so tell me in the comments. Which of these would you least want to be infected by? I'll give you mine at the end. And it's the one nobody expects. Every parasite so far has worked from the shadows, hidden inside its host. This next one does the opposite. It forces its host out into the open. On display. The Green-Banded Broodsac is a flatworm that's swallowed by a snail. And then it does two remarkable things at once. First, it grows pulsing, brightly banded sacs that push up into the snail's eye stalks, swelling them until they throb like fat, colorful caterpillars. Second, it rewires the snail's behavior. Instead of hiding in the dark, the infected snail crawls out into open, sunlit, exposed places. The result is a snail waving two pulsating lures in broad daylight, irresistible to birds. A bird takes the eye stalk, the parasite breeds inside it, and the snail, which usually survives, simply regrows the stalk, ready to be used all over again. A snail loses its eyes. This next host loses something far worse, and is chemically driven not to care. Massospora, the cicada fungus. It consumes a cicada from the abdomen forward, replacing the rear third of its body with a solid plug of spores. And yet the cicada keeps flying, feeding, and trying to mate, which is exactly the point. Scientists call them flying salt shakers of death, scattering spores everywhere they go. How does an insect missing a third of its body keep going? The fungus doses it with a chemical cocktail that includes a stimulant related to amphetamines and psilocybin, the active compound in magic mushrooms. Driven and tireless, infected males even imitate the wing flicks of females to draw in other males, spreading the fungus to both sexes at once. Which brings us to the last specimen, the one I promised would force its host to drown. The horsehair worm. It begins as a tiny larva, swallowed by a cricket. Inside, it grows and grows, coiling through the body cavity until it's often 3 times the length of the insect it lives in. Then, when it's ready for water, it makes the cricket do the one thing no cricket would ever do on its own. It heads for a pond and jumps in. The cricket drowns, and the worm uncoils from the body and swims free. How does a worm rewrite an insect's instincts? Recent research suggests it can take up the host's own genes and use them to build proteins that interfere with the cricket's nervous system, turning the animal's biology against itself. So what do all of these share beyond the nightmares? Every one points to something genuinely unsettling. That behavior, the urge to run, to hide, to mate, to survive, isn't sacred. It's chemistry, and chemistry can be hijacked. These parasites have no plans and no malice. Evolution simply favored the ones whose hosts climbed, walked, or drowned exactly where the parasite needed them. That's the real lesson of the lab. A mind runs on machinery, and machinery can be driven. Oh, and my answer? The one I'd least want isn't the brain fungus or the wasp. It's the hair worm. Because you'd feel completely normal right up until the moment you decided, for no reason you could name, to walk into the water. If this is your kind of weird, the next file is already on the shelf. I'll see you in the lab.